Good morning, students. Today we are discuss about internal portion, Gauss law and its application. First one you see electric flux. Okay, what is the electric flux? The number of electric field lines crossing a given area kept normal to the electric field lines is called the electric flux. Okay, so electric flux is number of the electric field lines crossing given area. So this and all what number of electric field lines. Okay, this is the I am taking to the one positive charges. This positive charges going to this side and this side, the plus side. Okay, after that more flux there, more lines. The electrical fielding is here, more lines. First you see I am taking to that point Q plus Q, right? So this is the electrical field line. This is electrical field line. This is electrical field. This is. So here you see that this then more electrical field lines here having. Okay. So I kept two plates. I kept one plate. I near the point charge near the I kept one plate, and some of the distance I kept that one plate. Okay. So next what happened? You see that you count that this plate how much of the crossing the electrical field lines. You see 1, 2, 3, 4, 5, 6, 7, 8, 9. So this plate having the 9 electrical field lines. Okay. Now you see this plate you are counting that electrical field lines. 1, 2, 3, 4. So here the 4 lines only. Okay. So where the electrical field more than plate A. The plate A only having the more electrical field. That is flux. More electrical field. So this one, the more electrical flux, we have to denote pi. You see, this is the pi. So that one you are taking to the more electrical field pi A, plate of A. Okay, so this plate it's a more electrical flux having. So here that the very less flux only. Here 9 electrical field. Here the 4 electrical field. So that flux is a very less only. So the plate of B, electrical flux B is a very less only. So the plate pi A greater than pi B. Pi A greater than pi B. Why means? So here having to the more electrical field, here having to less of the electrical field. So where it's a more electrical flux, here only the electrical flux. What is the electrical flux? The number of electrical field lines crossing area. Yeah, given crossing area. So here only having the more electrical flux. That's why we are telling pi A greater than pi B. Okay. So now this is the scalar quantity. So the electrical flux unit vector is Newton, you see. Newton meter squared coulomb minus 1. Power of minus 1. Okay. Electrical flux is a scalar quantity. It is SI unit of Newton meter squared coulomb power of minus 1. Okay. It can be positive or negative. The electrical flux having to the positive or negative also. Right. So that one I explained here, no? That one. Okay. The electrical field of the point charge is drawn in the figure. So the electrical point charge, electrical charge point P. You want to fully have to electrical field that it's a surrounding. Consider the two small rectangle area element place the normal to the field at a region A and P. So we are kept to the two electrical plate, normal plate. So here one and here one, right? Then the elements have the same area. The number of electric field lines crossing the element in the region A. So the region A, this plate is a more electrical field lines crossing. Okay. Then the crossing the elements in the region B. Therefore, the electrical flux in the region A is more than that the region B. The electrical field strength for the point charge decreases as the distance increases. Okay. So you see that point, this plate, the region of the plate B, the point learn the charges of the away from that, away, ரொம்ப long distance we are keeping that the region of the plate B. So that distance, the point charge, the plate, the distance is a very long distance. So that's why the electrical flux is a decreases. Electrical flux is a decreases. The distance is a long means the charge, the electrical charge, that charge plus Q charges to the kept the plate, the region of the plate in between of the distance is a increasable means the plate having the electrical flux is also a decreases. The flux is a decreases. Distance is a increases means flux is a decreases. Okay. So distance, the plate to the charge Q in between distance a decreases means very less distance means the flux is a increasable. The flux is a increasable. You see the charge plate in between gap it's a small only. That's why the charge, the electrical field, that electrical field lines is a crossing the plate is a more. Okay, so that's why. Okay, this is the electrical flux. Okay, now so next we go to that electrical flux for the uniform electrical field. Uniform electrical field. So now we are draw to the uniform electrical field. This and all what uniform electrical field. Okay, va? So the total I denoted to the E vector. So this area I kept to the one plate I kept. So you see that plate inside moving to that electrical field. How many electrical field it's crossing that plate? You see 1, 2, 3, 4, 5, 6, 7, 8. Right? So that's why that's plate having to the more electrical flux. So that one we have to taking to the E into area. So E means the electrical field. Electrical field into A. So that's why. So the electrical flux is denoted by pi E equal to electrical field and area. Electrical field and area. Okay. Now you see that second diagram you see. So the same like only we are taking to the uniform electrical field we are taking. Uniform electrical field we are taking. But I kept that the two electrical field in between I kept to that one plate. Okay. You see any electrical field line cross the plate? No. It is not cross the plate. Okay. So that's why we are telling that the electrical flux is a 0. So pi E equal to 0. Here no electrical field. This area it is not having a electrical field. Okay. So electrical field having means here we are telling the electrical flux. So number of electrical fields line cross the area we tell to that electrical flux. Okay. Here not crossing the electrical field lines. So here not having to the electrical flux. So that's why we are denoted pi E equal to 0. Okay. Now you say next. So now I cross I am taking to the uniform, third diagram you see, I am taking to the uniformly electrical field I am taking. I kept the one plate. Okay, see you see this side and this side and this side moving to the electrical field. So 1, 2, 3, 4, 5, 6, 7, 8. 8 lines are crossing the area. Okay. So now I am taking to this point, I am taking the electrical flux is here going this side means. So you see here creating to the one angle. So this side and this side also moving. Okay, electrical flux. So here having this point means the flux point, the electrical field lines moving here also. Right. So here creating to the theta. So the near creating the theta, the both side we are taking to this side the E cos theta and this side we are taking the E sin theta. So E means the electrical field lines, sin theta and cos theta we are taking to that. Okay. Now, so how much of the electrical flux having this area? So we have to E into cos theta, the area, this area only we have to find out. No, not here this area, we are find out that this area only we are find out. Okay, the angle produced no this area. So now we are taking to this value. So E cos theta into A. A is a this area, in the area. We are taking to the area. Okay, how to we are writing that? Pi E equal to E A cos theta. E is a electrical field, the cos theta and area. A is a area we are taking that. Okay. So now you see that here EA equal to cos theta. Now we are applying to that cos theta 0. So cos 0, the theta value equal to 0 means you take the cos 0. So cos 0 we are applying here E A cos 0 na what come? Cos 0. So cos 0 value what? 1. Appa E A into 1. Appa value is here E A. So pi E A. So that's one coming here. It's a parallel only, no? Okay. E A. Next you see that. Now we are giving to the 90 degrees. Now we are giving to the cos 90. So E A cos 90. So cos 90 what value? E A 0. Cos 90 what? 0. So what happened? It says 0. Flux E equal to 0. So that's why here the electric field, it's a 90 degree. Okay, what happened? The flux is here 0. So that's why they are given here. Okay, this point. Right, ma'am? Thank you, children.